Hello everyone, welcome back again to my channel. In this tutorial we are going to simulate the reinforcement of the slope. So we will investigate the effect of reinforcement of the slope on the factor of safety of the slope. So we will run two analyses. In the first analysis we will investigate the factor of safety of the slope without the reinforcement. And in the second analysis, we will investigate the factor of safety of the slope, including the reinforcement. Also, the reinforcement material used in this example is the geogrids. As you see, this is our model. It contains of two soil layers: the bottom soil layer, which is dense soil, and the embankment or the upper soil layer, which is less dense soil used in this example. On the top of the embankment, the line load is added, and the amount of the load is 10 kilonewton per meter, as you see. So first of all, the geometry of the model has to be drawn. So the geometry can be drawn using this icon, create soil polygon. After drawing the soil geometry, the geogrids also has to be modeled. The geogrids can be modeled using this this icon. We click on create line, and in here we have create geogrid. So after creating the geogrids, the negative and positive interface also will be defined to define the interface between the soil and the geogrids. And these are the material properties of the soil for the bottom layers and for the embankment. In the bottom layer, the dense soil was used, and this is the properties of the soil. The hardening soil constructive model has been used for this soil under the drain condition. Also, these are the shear strength properties of the soil. This is also the soil material which was used for the embankment. In this soil model, also the hardening soil model was used under the drain condition, and also these are the shear strength properties of the soil. For the geogrids, also the material has already been defined, and these are the properties of the geogrid. So after drawing the geometry of the soil and the geogrids, each material has to be assigned to the soil, and the geogrids material also has to be assigned to the geogrids. So after the geometry has been drawn and the materials has been assigned, after this step the model has to be meshed. That's why we proceed to mesh menu, and in this example the medium mesh has been used, and we can view the mesh results of the model. As we see, this is the meshed model. In the embankment, the finer mesh has been used. The bottom soil layer, the coarse mesh has been used automatically by the program. So after meshing the model, we go to the staged construction. Since the model is not horizontal, that's why in the initial phase the gravity loading calculation type has to be used. So after the gravity loading, we will add the surcharge load. So in this phase, the plastic calculation type will be used. And after the surcharge has been applied to the top of the slope, after that the factor of safety analysis will be performed to calculate the factor of safety of the slope. This is the factor. This is the factor of safety of the slope without the reinforcement. So in the second analysis, after the gravity loading, we will install the geogrids on the slope. That's why in this stage also we will use the plastic calculation load type. And after the plastic analysis, we will also again calculate the factor of safety of the slope. In this stage also the calculation type has to be set to safety analysis. So in the initial phase, the geogrids interface and line loads has to be deactivated because it is initial phase and we don't have the we don't have any loads on the top of the slope or geogrids. So after the initial phase, we add another phase, and in this phase, the surcharge load is activated. It should be included into the calculation. So after the surcharge load, the factor of safety will be calculated. In the second analysis, after the initial, the geogrids and the interface has to be activated to take it into the account. So after installing the geogrids, the factor of safety again will be calculated and the analysis can be performed. So before performing the analysis, one point can be selected using the select point for curves to calculate the factor of safety, again the displacement. So in this example, the analysis has already been performed. So right now we can see the results. To see the factor of safety of the slope, in here also we can check it. For example, in the first case, the slope without the reinforcement, we click in here and we check the factor of safety. As we see in this example, the total factor of safety is 1.13. While after installing the geogrids and calculating the factor of safety again, we see the factor of safety increases to about 2.3. So this example tells us how the reinforcement of the slope increase the factor of safety of the slope. Also we can view we can go to view calculation results and see the failure surface and deformation of the slope. So in the deformation menu, we can see after the performing the surcharge load, this is the deformation of the embankment, and this is the deformation of the embankment after installing the geogrids. Also we can check the total displacement. This is the total displacement after performing the surcharge load, and also this is the total displacement after using the geogrids. So in this example, the most important thing is the factor of safety. To see the failure surface of the slope, we can check it in the deformation menu, and after that incremental strain, and in here we choose this one. So uh, before reinforce before reinforcing the slope, this is the most critical failure surface of the slope, and after reinforcing the slope with geogrids, we can see in here the critical surface happens in this region and in this regions also. So to see the factor of safety against the displacement, we click on the curve manager and we select new, and in the x direction we choose the point which we selected before, which is at the crest of the slope, and we chose the total displacement, and in the y direction we choose the project and multiplier, and we choose the safety factor, which is sigma MSF, and we click OK. So now we want to compare the two factors of safety together. So the factor of safety of the slope without reinforcement and the factor of safety of the slope with reinforcement. So in here we just choose the factor of safety before reinforcement, which means this is the factor of safety of unreinforcement slope. In here also we can change the curve title. We can write the unreinforced slope. We click OK. Also we can add another curve for the factor of safety after the reinforcing the slope with geogrids. So in this case we will just check the factor of safety of the slope after reinforcing the slope with geogrids. In here also we can change the curve title. We will write the reinforced slope. So in the chart title we can change the scaling to manual, and we will choose the maximum to 15. As you see in here, the blue one is the factor of safety of unreinforcement slope, and the red one is the factor of safety after reinforcing. We can see the factor of safety after reinforcement, after reinforcing the slope is about 2.28, and before reinforcement it's about 1.13. So this example showed us the importance of reinforcement of the slope and how it increased the factor of safety of the slope. Thank you for watching this tutorial. To see more tutorial about slope stability and other geotechnical applications, please do not forget to subscribe to our channel.